Good morning, welcome back. This video is for both Algebra 2 and Pre-Calc. We want to remember how we get sine, cosine, and tangent from our unit circle. So try these, please. So for sine of 45, it is the second number. That's the square root of 2 over 2. Cosine, 150, that's the first number. That's going to be right here, negative square root of 3 over 2. For the tangent, we have to do sine over cosine. Now, this is how we would truly have it, but we would notice that the numerator of this term here is negative 1 divided by just the negative square root of 3. So this is a faster way to get there. I could have the negatives on there, but the negatives are going to disappear. And multiply by square root of 3 over square root of 3, we end up with square root of 3 over 3. I'm going to use those today to find exact values of functions not on the unit circle. So where the heck is 22.5 degrees? Can I find it anywhere here? What I could do is take 45 degrees and cut it in half. That would get me 22.5. How about 75 degrees? Well, 75 is somewhere about in here. I could take these two and I could add them. And that would get me the one I want. How about 15? If I have the choice of using things in the first quadrant, I am, because here I deal with positive numbers all the time. So I can do 45 minus 30. I could have done these guys here. 150 minus 135. But if I do those, I'm going to end up dealing with negative numbers sometimes. So these are the trig identities that we're going to look at using. They are all on the worksheet that I sent you. Half angle identities, double angle identities, and addition and subtraction. And where they are on that reference page, here we have addition and subtraction, and the double and the half. In the halves, you notice that we have plus and minus. If we have an exact value, we might think, which quadrant is it in? Is sine, cosine, or tangent positive or negative? We probably already have that written on our unit circle. So the first thing we want to do is figure out another way to get there. And we already showed the 15 degrees and how we could get there. Here's just a couple of the ways. I could have done 30 divided by 2. Can I double an angle? Can I cut an angle in half? Can I add 2 or subtract 2 angles? So we're going to start out using the half angle identity to find the sine of 15. This is the identity, and 15 is in the first quadrant, so I know it's positive. So I plug in 1 minus, well, what's the cosine of 30? So I'm looking for the sine of 30 divided by 2. And I am only going to pick the positive because of where it is. Cosine of 30. Cosine is my first number. That's the square root of 3 over 2 divided by 2. I have a whole bunch of cleaning up to do in here. So I'm going to start out with that. And I do need these two things to be under the same fraction. That's going to give me 2 minus square root of 3 over 2. I still have this guy, and I'm going to have to copy dot flip-flop him. That puts the 2 in the denominator. So this becomes so the denominator does simplify, and the numerator is the square root 2 minus square root 3 all underneath the square root sign. I know, it looks ugly, doesn't it? But that's the way we're going to keep it. This is going to be our final answer. So now let's take a look at the half angle identity, and we're going to use it to find something that we actually can find, which is the cosine of 60. Cosine of 60 we have here 1/2, but we're going to use this guy right here. So let's see what that would look like. So we're going to end up doing the cosine of 120 divided by 2. 1 plus the cosine of the 120 is a negative 1/2 divided by 2. All of those steps that we've been using on the last assignment, we're going to need to use to simplify this. Let's deal with the top. Can we do 1 minus 1/2? 1/2 over 2. That's the copy dot flip-flop. 1/2 times, and when we flip-flop 2, we get 1/2 again. So we have the square root of 1/4. And that we can take the square root of, we get 1/2. So they don't all stay ugly like the last one. The next section will have double angle identities. We're going to find the double identity for cosine of 60. Now these do happen to also be on the unit circle. This is an exercise in how to get there another way and how to use your algebra steps with things that are as complex as sines, cosines, and tangents. What you'll notice on the worksheet is there's multiple versions. It doesn't matter which one you pick. These are equal. So everything I'm going to plug in here is going to be about 30 degrees, not 60 degrees. So I'm using the top one here, cosine squared theta. That means I'm going to take the cosine of 30, those are in here, cosine of 30, and then I have to square that whole thing, minus the sine, and I have to square that. So how does that simplify? Square both of these, and I get 3 over 4 minus 1 over 4. So that becomes 2 over 4. We know that simplifies, always simplify to 1/2. And did we get what we were looking for? So I do need to see your work because that's what I'm looking for. So 270 is 135 times 2. So everything I plug in here is from 135. Let's just use a different one. If I have one that's simpler, I might choose sine instead of cosine. These are both square root of 2's. So I'm just going to use, let's use the third one actually. 1 minus 2 times square root of 2 over 2. That is the part, and only that part, that gets squared. Now it's just number crunching. So when we simplify this, we get 1 minus 2 times square root of 2 squared is 2, square root of 2, 4. Well, that whole thing simplifies to 1. So our cosine is 0. Is our cosine of 270 actually 0? Yes, it is. The next ones we'll take a look at are addition and subtraction. They're in a different section on your worksheet. This is the equation for the addition property for sine. And for sine, we're going to use 300 plus 45. And if we use that, I don't usually write this step down, but you're absolutely welcome to. This is to keep track of where am I doing the sine or cosine of 30, where am I doing 45. This is helpful, but I don't need to write it down. The step that I usually do go straight to is I know I'm doing sine of 345. And now the sine of 300 is here, negative. Square root of 3 over 2. I'll write these out a little bit better on the next page. Cosine of 45, that's square root of 2 over 2. In this case, watch here because this is where it changes. In this case, it's plus. Then I need the cosine of 300, that's 1/2, times sine of 45, we're back to square root of 2 again. Okay, not horrible. Those are a little bit better on the next page here, so now I need to simplify. When I simplify these, I'm going to multiply across the top. Negative square root of 6. 2 times 2 is 4. Plus, across the top, square root of 2, also over 4. So both of these will go together. Now, I can't combine these, it's plus. So I can either write the 6 in front or equal. I could write the square root of 2 in front because that way I'm not going to lose track of this negative sign. And that's my final answer. So for sine of 15, I'm actually going to use 45 minus 30. And that's the subtraction rule. The only thing that changed, right there, everything else is exactly the same. So in this case, if we're writing it out, so what I get when I set this up, sine of 45, square root of 2 over 2. Cosine of 30, that's the square root of 3 over 2. This one is a subtraction. Cosine 45, sine of 30. And the numerators will simplify to the square root of 6 minus the square root of 2. And since the denominators will be all the same, it's going to be over 4. Final answer. Final answer, ugly but exact. Last one we'll work on is the tangent of 165. 165 I can get to doing 120 plus 45. So we do the addition formula. You do notice this one is a fraction. So if we're setting this up, sometimes we keep track of these two here someplace. So we just know which ones we're plugging in. Tangent of A, tangent of 120. How do we get there? Tangent of 120, remember to look at your numerators only. The numerators here are square root of 3 over -1. So the tangent of 120 is negative the square root of 3. I'm also going to put that down here as well. Tangent of B is 45. Well, square root of 2 over 2 over square root of 2 over 2, numerator divided by numerator becomes 1. In the denominator, I have 1 minus negative the square root of 3 times 1. So how does that simplify? I am going to clean this guy up. I'm going to write it this way just because I'm a little bit less likely to lose that negative sign. And in the denominator, I have 1 minus a negative is plus square root of 3. Remember, I'm not allowed to leave the square root in the denominator. So what I need to multiply that by is the conjugate. And that's going to be 1 minus the square root of 3. Top and bottom. And FOIL. When I FOIL the numerator, I get 1 minus the square root of 3 minus the square root of 3 plus 3. Square root of 3 times square root of 3 is square root of 9, 3. In the denominator, if I do the whole FOIL, I get 1 plus the square root of 3 minus the square root of 3 minus 9. So those simplify. In the numerator, I end up with 4 minus 2 square root 3's. In the denominator, these two cancel. 1 minus 9, watch out, it will usually be a negative, negative 8. Couple more steps to try to get this, couple more steps to try to clean this up. My preference is not have a negative in the denominator. All of these are divisible by definitely 2. So I'm going to divide every single term by negative 2. So for positive 4, I get negative 2. Negative 2 square root 3 becomes positive square root 3. Negative 8 divided by negative 2, positive 4. Now I do prefer positive in front of negative. So that would be acceptable. The other way I could write this, I could actually do both of these divisions, and I could end up with negative 1/2 positive square root of 3 over 4. All three of these are acceptable forms. This is not. Okay, so your homework again is on a worksheet. Both of these classes are doing the same thing. I will set up Google Class Meets on Thursdays so that we can do homework help with this due on Monday. Have a good day.